We have been seeing the proof of the number of subsets of a set of n elements from week 1. We gave first a combinatorial proof for it using the binomial theorem, and then we moved on to show a bijection using 3-digit binary numbers to all possible subsets. Well, now we'll move ahead and give a mathematical induction proof for showing that all possible subsets of a set of n elements are 2 to the nn number. How do we proceed? As you all know, what is our statement given here? It is, I'll consider it to be P of n. It is, set with n elements has 2 to the n subsets. So this is my statement. I'll use induction to prove this. You must be familiar with how induction goes on. We'll first consider basic step and then we'll see what is the hypothesis and so on. If you are still not familiar, you'll understand with this problem and the further problems. So what is the first step? I'll consider a basic step where I'll consider the number of elements in A to be 1. Please note, what are we inducting on? We are inducting on n here. Okay? So I'll write basic step, n is equal to 1. So what does n is equal to 1 mean? The cardinality of A is 1. So I'll assume A is equal to the set, singleton set A. So A is my element here. Okay? Now, what are the elements in the power set of A? Very obvious, phi and A itself. So for n is equal to 1, the given statement holds true. For one element, we have two subsets. So this was the basic step. Now let us move on to the induction hypothesis. What do I mean here? I assume that the statement is true for some k elements. So this I'll call it as induction hypothesis. Do not worry much, it is just an assumption. I'll be using this for my next step. So induction hypothesis goes like this. I assume set with k elements has 2 to the k subsets. Now, what do I have to prove next? I have to prove that, so to prove is set with k plus 1 elements has 2 power k plus 1 subsets. So I have to prove this. So what do we have to do now? I have this set B which has k plus 1 elements. How am I going to proceed? I'll break this into two parts. One set having k elements and a singleton set. Okay? So you may want to pause here and go back to the induction hypothesis. Why? Because the statement, we are assuming that the statement holds true for k elements, which is the reason why I'm considering a set with k elements here. So let me assume B dash is such a subset of B which has k elements. So I'll write B to be B dash union X. So B dash is a set with k elements and this is a singleton set. Now, please listen. I'll consider a subset of B dash. Let me say it as C. And how many elements are there in the power set of X? It is phi and X itself. Correct? So, now observe this. C union null is C itself and C union X. These two sets are subsets of my set B. Is this point clear? So I am getting two subsets here. One is C and one is C union X. This singleton set X. So, where did I initially start? I considered a subset of B dash and I ended up having two subsets of this set B. So, what can I conclude? For every such subset of B dash, C, T, S, whatever, for every such subset of B dash, I am going to end up having two subsets of B. Now, how many such subsets are there? 2 to the k. How did I get this? From the induction hypothesis. So, B is a set having k plus 1 elements, and I'm getting every time for every subset of B dash I'm getting 2 subsets. Hence B will have 2 into 2 power k subsets, which is 2 to the k plus 1. Hence I've concluded that B, which is a set having k plus 1 elements, has 2 to the k plus 1 elements in its power set.